Hi guys, in this session, as I told, we are going to discuss about introduction of tree data structures. So in the last classes, I gave you one of the real-time example of what is a tree and how we are going to correlate all the data and how we are going to store it, right? So what I told, so tree is a family of collection of data interlinked within each other, right? So we have n number of trees, that is we have various types of tree representation. Okay, so here this is one of the data structure, that is we are going to organize the data in the tree format. Okay, so we discussed stacks, queues and linked list and circular queues and so on. So what are all those? So those are all one type of representation of data, that is where we are going to store those data in my memory. So this is also one of the type. So we can store the data by using arrays and linked list, isn't it? So array can be used for implementing queues, stacks for storing, or linked list can be used for storing the data in the format of queues or in the format of stacks, isn't it? So we are going to use another way of data organization. So it is nothing but tree data structure. So we are going to use a format of organizing the data. So we can store these types of data either by using linked list or either by using arrays. Okay friends, so stacks, queues, trees are one type of format that we use for storing the data. Linked list and array are used for storing, actual storage. What we are going to implement it by using these types. Okay friends, so now we are going for conceptual discussion. So what is a tree? So tree is a family of data collections, isn't it? So last class I represented, isn't it? So parent, children, siblings and so on I told. You just watch that video so that you will be having a relationship between what I told in the last class and what we are going to discuss it now. Okay. So these are all the important points of tree data structure. So what is the first point? See, already I told we are going to have a brief discussion. Okay, we are not going to see in a very detailed manner. Okay, so it will be very confusion for all of us, isn't we cannot able to remember all the points. So we are going to take the important points, just grasp it in mind so that we can easily remember at any sequence. Okay, so now you see tree is called as a non-linear data structure. So what is non-linear data structure? We are not following any sequence for storing the data. Am I right? For stack, what we will be doing? We are storing the data like a shelf. So for that also I give you an example. For queue, we are going to store the data in line. Am I right? Then for linked list, we are using chain format for storing the data. But in tree, we are not using to follow any order. Okay, so the data are stored in non-sequential representation, not like that of queue or stack. Keep that in mind. So it is a non-linear data structure representation. Okay friends, so next you see another important point. So it is a non-cyclic data structure. So what is called cycle first? Tell me what is the meaning of a cycle? So cycle is something but you are going to start from the first and we are going to travel and once again we are going to end in the same place. That is called as a cycle. So starting and beginning are the same location. But in tree, if you just watch, for example, if I am going to start from A, C, F, G, H. Once again, is there any possibility for reaching the A? No, that is no possibility, isn't it? So, it is forming a non-cyclic data structure of storing the data. Okay, so this is another very important point they may ask in competitive examinations. Okay friends, then next point is, it is a hierarchical data structure representation. So what is called hierarchy? So hierarchy is nothing but we are going to follow some relationship between each and every data. Okay, so collection of relationships present in a family I discussed in the last video. So that collection of family we are using that for finding where the data is being presented which location. So this is the link. Okay, by using that link, that is this is the parent, this is the children, these are all the siblings. Okay friends, so by using that relationship, we are using this hierarchical data representation. So the meaning is hierarchy. What relationship we are following for finding the data is called as a hierarchy. Okay, so these are all very important points friends, right? Make a note. So next you see, we are going to discuss now the tree terminologies. What is called terminologies? The meaning is what are all the important points or terms we must have to remember for finding the data present in a tree data structure. For example, what is a node? What is a tree? Okay, what is a children? It's like this, we have n number of terms. Headings, that is the meaning is, I'm just telling about terms or headings or the meaning of each and every parts. So that we are going to discuss how we are going to find a respective data. Okay, so that we are going to see now. Okay, so up to now you might have a clear idea of what we are discussing about tree. So friends, now we are going to start with tree terminologies. So before discussing this, I just want to explain you what are all the important terms that we are going to use, that is important parts of a tree data structure. Normally a tree is a combination of nodes and edges. What? So a tree is a combination of nodes and edges. This you must have to keep in mind. Okay, so a tree is having the combination of nodes and edges. So here, what is a node? So these elements, isn't it? So these elements are called as a node. So a node consists of the actual data. So what is edge? So edge is nothing but what is the actual path that is being present to traverse from one data element to another data element. So sequence of connectivity between two data is called as an edge. So these are all called as edges. Right friends? So this is called as your node. Right, all these are called as your node, and this actual connectivity is called as your edges. Right friends, so next we are going to see its terms. So first you see, we are going to discuss about root. So what is a root? So this first element through which we are going to initialize constructing the data is called as your root node. Okay, so this is called as your root node. The first and foremost element present in your tree data structure is called as your root node. So this is your root. Non-terminal or non-leaf nodes or internal nodes. First you tell me what is a node. So these are all called as your nodes. So in that node, this is your parent node. Already told, isn't it? What is a parent? What is a child? So this is your parent node, and the child of this parent or the children of this parent is B and C, isn't it? So for D and E, B is the parent, and F and G, C is the parent. Similarly, I can go on till. Am I right? So now, what is a non-terminal? What is called as an internal node? Okay, so internal node is nothing but the nodes that are present in between the root node and these last nodes. Okay, can you understand? So the nodes that are present in between this node, in between the root node and this node, right? It is called as your non-terminal node, or we can also call this called as an internal node or non-leaf node. What is called leaf? In a tree, if you tree, what is a leaf? So leaf is a place where the growth of the stem or the branch is going to get completed, isn't it? So here also the tree is going to get stopped here in this location. Okay, after that there are no data present, isn't it? So these H, I, J, L, K, M, all these are called as your leaf node. Okay, so this is a place where the tree is getting terminated or ended. Can we tell like that, isn't it? So terminated or ended or stopped. So we call them as terminals. Okay, so these nodes are called as your leaf node because there is no growth hereafter. So we call it as a leaf node. So another name is, we can call it as terminals. Okay, can you understand? So leaf node or terminal nodes, right? So the nodes that are underlying between this leaf node and the root node are all called as the what? Nodes that is present in between. So they are all called as internal nodes. Like that also I can tell, isn't it? So these are all internal nodes. So this I can tell it as an external node, right? Can you understand? So these are all internal nodes. Okay, so this is your root node. So the leaf nodes are also called as terminals or external node. That is, these nodes are getting stopped, isn't it? So this we can see it in through outside view. So we can call it as an external node. So these are all present in between. It can be seen or not seen. So we call them as an internal node. So the another name is non-terminal. This is terminal ending. So the opposite of terminal is non-terminal, isn't it? So we are referring it as non-terminal, non-leaf node, because they are not leaf nodes, isn't it? So these are all not leaf nodes. After that also the tree is getting grown. So we are calling it as a non-leaf node, right? So internal node, just now I told. So now tell me, what is another name for leaf node? Terminal nodes or external nodes, right? So please make a note of it. These are all very important points. They may give any key terms in the question. Okay, you must have to recognize and then you must have to answer. Okay, so this we have finished. So this also we have finished. So next we will see siblings. So what is a sibling? I told you in the last class. So what is a sibling? Please recall and tell me. So friends, if there are any new viewers who are watching this video, I request you to watch the previous video of the introduction of binary tree and then come over here, right? With that example only you will be able to relate and keep it in your mind. Okay friends. So what is siblings? Brothers or sisters. Okay, brothers or sisters. Like this I can tell. So for B, I have D and E as my brothers or sisters. We can tell in common as siblings. For C, you have F and G as my brothers. For A parent, I have B and C children. So they are all brothers or sisters. Then for D, H and I are my brother. For E, you tell me. Only J is the only one child of E. So there is no sibling for E. Sorry, there is no sibling for J, isn't it? So E is having only one child. For F, you see L and K are siblings. So they are brothers and sisters. For G, M is the only child. So no sibling for M. Okay, so this is called siblings, brothers or sisters. So what is an edge? Just now I told, the actual path through which we can traverse to search any data is called as your edge. A connectivity that is being established between nodes. Okay, so next you see degree of a node. So what is the degree of a node? Degree. So degree is nothing but total number of nodes that are being attached with one node. Please make a note of it. So degree of a node is nothing but, for example, you take this node. For the node B, what is the degree? Total number of nodes that have edges to B, right? So total number of nodes that are being connected to B, right? So for B, D and E are having the direct edges, am I right? So the degree of B is 2. Can I tell like this? Now tell me for A, what is the degree of node A? So total number of edges that is being directly attached with A is B and C. Am I right? So for this also the degree will be 2. So now you take for E. Okay, for E. So what is the degree of E? The total number of edges that is being directly attached with J. Isn't it? So only one node, only one edge is being connected. So it is going to be 1. So like this you must have to calculate, right? For specific node, if they ask a degree, you should have to calculate that like that. Direct edges that is being attached. So next for tree, you tell me, what is the degree of a tree? Please make a note of it. Maximum number of children that is being present in the overall tree data structure is called as the degree of a tree. That is, for each and every node there are some children. A node which has maximum number of children. Okay, a node which has maximum number of children is called as the degree of a tree. Okay, for example here, we are discussing about binary tree. Okay, already I told we are going to start up with binary tree. So in binary tree, if you see, what is a binary? Any two values, 0 or 1 is called as a binary. So here in a tree, that is a parent may have one children, two children or no children. So that is called as a binary tree. So binary tree is going to have either one children, right, or two children, or there will be no children. So that is called as your binary tree. Keep that in mind. So at the maximum, a binary tree can hold only two children. Any node, okay, any parent will have at the maximum only two children or minimum one children or no children. That is called as a binary tree. So here, if I want to find the degree of a node, sorry, degree of a tree, so what is the maximum child that any node is having? Okay, so here you see 2, for B also 2, for this also 2, 2 and 2, for E is having only 1 and for J is 1. So either 2 children or 1 children, or it is having, the leaf nodes are having no children, am I right? 0, 2 and 1. So in that, what is the maximum value? So here the maximum value is 2, isn't it? So the degree of a tree for this data structure is 2. Okay friends. Now for example, if L, okay, if L is having 5 children, okay, if L is having 5 children, now in this case, now this is not a binary tree because one of a node is having 5 children, so we cannot take this as a binary tree. So for your understanding, I am taking here as 5 children for any one node. So now they are asking you to find what is the degree of a tree for this data structure. Okay, so now what you will be telling, for the whole data structure, one of the node will be having 1, another node will be having 2, and this node is having 5 children. So what's the degree of a tree? Maximum number of children in a tree is called as a degree. So here the degree of a tree will be 5. Can you understand? So like this only you must have to calculate the degree of a tree. So maximum number of children present in any one of the node of a tree data structure is called as your degree of a tree. Can you understand friends? Right. So now we will go for levels. Okay, what is called as a level? So sometimes they may ask in the question, okay, to find the level of a tree. Okay, so level is nothing but height of a tree. Like this also I can tell. So we can also tell that each and every stage of a tree data structure is called as a level. So this is one level, right? So this is one level and this is another level and this is another level. Okay, for example, if it is growing like this, for example, W, X. Okay, so this is one level, then this is another level. Okay, so total number of stages, equal number of stages that is being present in a tree is called as a level. Okay, so here you have 1, 2, 3, 4 and I have drawn here, isn't it? 4, 5 and 6, right? See 1, 2, 3, 4, okay, 5 and 6. So there are 6 levels, but you must have to start from 0 like arrays. So you must have to start as level 0, level 1 like this. Okay, so this is going to be level 0 and this will be level 1. Okay, so this is going to be level 2. Okay, so this will be level 3. So next you see level 4 and this is level 5. Can you understand? So here for this tree, the total number of levels, okay, so the total number of levels present in a tree is 5 because we are starting from 0. Keep that in mind. Level has to be calculated from 0. So now you just tell me, in level 1, how many number of nodes are present? Okay, in level 1, how many number of nodes are present? B and C. Can you understand? So next, for level 2, how many number of nodes are present in that level 2? D, E, F and G. So 4, right? So for level 3, how many number of nodes are present? 1, 2, 3, 4, 5, 6. So there are 6 number of nodes. Then for level 4, how many nodes are present? Only 1. Then for level 5, 1. So like this, they will be asking you questions. Please put an example and make a note. Okay friends, I think so up to now you will be clear. So next you see for successor and predecessor.